In this video, let's go ahead and improve our understanding of powers together. Now keep in mind, powers are just a shortcut way of writing repeated multiplication, kind of similar how multiplication is a shortcut way of writing repeated addition. So to start off for questions 1 through 4, let's go ahead and just identify the base and the exponent for each of these powers. Then we're going to go ahead and expand each of these powers using a multiplication sentence. We're not actually going to evaluate or solve any of these, so don't worry about that part. For number 1, we have this 4 to the 6th power. This is right here to altogether, that's a power. The base here is going to be this 4. That's the base. And then this little 6 over here, the little guy, is going to be our exponent. So that's going to be the 6. What this really means is it's a shortcut way of writing repeated multiplication. This is really 4 times 4 times 4 times 4 times 4 times 4. So this would be a very big number, but this is what it would be like if you expanded it as a multiplication sentence. For number 2, we have this power of 1/2 to the 5th power. Our base here is just going to be the 1/2 though. Okay, so the base is 1 over 2, and the exponent is this little 5 up here, so that's going to be the exponent. If you go and expand this, typically we use parentheses if we're using fractions to keep it more organized, but it's 1/2 multiplied by 1/2, a third one, a fourth one here, and you guessed it, there will be a 5th half here. So this would be a half times a half times a half times a half times a half. For number 3, we have a power that is 0.3 or 3/10 raised to the 4th power. Our base here is going to be the 0.3 or 3/10. That's going to be the base here. As for the exponent is going to be a 4. So what does this mean? This means that we have 3/10 multiplied together 4 times. So typically for decimals as well, we're going to use parentheses just because if you use a dot for multiplication, that's just a lot of dots to kind of write everywhere, whether it's a decimal or a multiplication sign. So parentheses are a good choice here. For number 4, we have this power of 2 2/3 raised to the 3rd power. Our base here is going to be the 2 2/3. Now, just to make things a little bit more clear, I'm going to turn this into an improper fraction. So 2 times 3 is 6 plus 2 is 8. So I'm going to write it's going to be 8/3. And if we raise it to what power? So this is the base here, but the exponent is going to be 3. So that's going to be the little exponent there. And if you expand this, I'm going to go ahead and write it as 8/3. And it's a good practice just to turn it into improper fractions, because if you're going to evaluate this later anyway or solve it, you can't multiply the mixed numbers as easily when they're written as mixed numbers. We typically like having a top and bottom or a numerator and denominator. Okay, so that's 1 through 4. Let's try another set of problems that are a little bit different. For 5 through 8, let's go ahead and see if we can go ahead and condense each of the following multiplication sentences. So we're going to be given the sentences, and we're going to go ahead and write them as a power. Then we'll go ahead and evaluate or solve them, and we'll show all of our calculations that we need to as well. So for number 5, we have this base of 2, and it looks like we have 1, 2, 3, 4, 5, 6 of them. So our power here is going to be 2 raised to the 6th power. Now for the value, this just means solve this thing, right? So let's see, 2 times 2 is 4, 4 times 2 is 8, times 2 is 16, 16 times 2 is 32, 32 times 2 is going to be 64. Now if you needed to write out any of the calculations, feel free to do so, but for me I think that was okay, but feel free to show any of the standard algorithm for the multiplication. For number 6 here, we have some fractions being multiplied together. If we're going to go ahead and write this as a power, we're going to write this 2/3 here as the base. And how many are there? Well, there's 1, 2, 3, there's 4 of these being multiplied together. So we're going to raise this to the 4th power. That's the little exponent. Now, what's the value of this thing? Well, what's nice about this is we can actually just take a look at the numerators first. So we have 2 times 2, which is 4, times 2 is 8, times 2 is 16. So we're going to have a numerator of 16 here. And then for the denominator, if we go ahead and multiply all these 3's together, well, these 2 3's make 9, and then the other 2 3's make 9. 9 times 9 is 81. So if you're going to go ahead and multiply these fractions together, you should get 16 over 81. All right. For number 7, it looks like we have this 7.3 multiplied by itself 2 times. So another way we could write this as a power is take the 7.3 and raise it to the 2nd power, right? That's another way you could write this. Now, what about the value? This one, I think I'm going to have to go ahead and show some standard algorithm here. I'm going to go ahead and ignore the decimals for now and just multiply 73 times 73. We'll deal with the decimals in just a moment. 3 times 3 is 9. 3 times 7 is going to be 21. So we have 219. Put a placeholder here. 7 times 3 is going to be 21. Carry the 2. 7 times 7 is 49 plus 2 is going to be 51. Go ahead and add these two partial products together. We're going to get a 9, a 2, a 3, and a 5. And then we ignored 2 decimal places earlier. So if we go ahead and put these 2 decimals back in, we should have 2 decimal places in our product here. So our final answer here is going to be 53 and 29 hundredths. This would be the value here. For number 8, we have this 3.5 raised to the third power, I think, because we have a base of 3.5, and there are 3 of them. Now, as a power, I like writing these as improper fractions, so 3 times 2 is going to be 6, plus 1 is going to be 7, so it's going to be 7 over 2. That's the same thing as 3.5, and let's just raise this to the third power here. Okay. Now, what if we're going to go ahead and write this out? Let's see. We have, in the numerator, we have 7 times 7 times 7. Which is really going to be what? 49 times 7. So let's see. I'm going to do some calculations on the side here. Let's do 49 times 7. And let's see. That's going to be 63. Carry the 6. 28 plus 6 is going to be 34. So we're looking at 343. So we know our numerator is going to be 343. Don't worry about making it a mixed number. Improper fractions are fine. And that's going to be the numerator of 7 times 7 times 7. And our denominator is going to be 2 times 2 times 2, which I don't know if we need to write out any calculations for. 2 times 2 is 4. 4 times 2 is going to be 8. So if you're going to go ahead and write this answer as a fraction, improper fraction is perfectly fine. It's going to be 343 over 8. Now, while that is the value, if you did want to practice writing this as a mixed number, if you took this 343 and divided it by 8, we could turn it into a mixed number. So you can't fit a whole number of 8s into 3, but you can fit in 4 8s into 34. 8 times 4 would be 32. If you subtract here, we'd be left with 2 left over. If you bring down this 3 here, 8 goes into 23, I think 2 whole times, so that's going to be 16. We get a remainder here of 7. So you could also write our answer over here, or the value of this, as 42 and 7/8. This would be another way you could write 343 eighths. All right, so the 7 times 7 times 7 came from the 7 to the third power, and then this 2 times 2 times 2 came from 2 to the third power. All right, let's try another set of problems. For 9 through 16, let's see if we can go ahead and expand each of the following powers. We'll write them as a multiplication sentence and then evaluate or solve. So for number 9, we have 3 to the 4th power. What does that really mean? It means we have 3 times 3 times 3 times 3. Now let's go ahead and evaluate this. Let's see, 3 times 3 is 9. So this right here is 9. And then this 3 times this 3 is also going to be 9. So 9 times 9, that's going to be 81. Okay, so cool. If you wanted to go in order and do 3 times 3 is 9, 9 times 3 is 27, you could do 27 times 3, that's also 81. For number 10, we have 2 to the third power. That's really the same thing as 2 times 2 times 2. Let's see, 2 times 2 is going to be 4, 4 times 2 is going to be 8. All right, pretty straightforward here. For number 11, if we go and expand this, this will be 4 tenths multiplied by 4 tenths multiplied by another 4 tenths. So what would this be equal to? Well, keep in mind that when you go ahead and evaluate these decimals, you can go ahead and ignore the decimals. So just multiply 4 times 4, that's going to be 16. 16 times 4, that one you might need to write out. So I'm going to go ahead and write 16 times 4. Let's see, that's going to be 60, that's 24, carry the 2. 4 times 1 is 4 plus 2 is 6. So we're looking at 64. So 4 times 4 times 4 is 64, but we should have here 1, 2, 3 decimal places, right? So I'm actually going to move our equal sign here. I'll put over here, we have a little bit more space, and we need 3 decimal places. So 0.064 would be our answer, right? We ignored 3 decimal places earlier, so we made it 1,000 times too big, so we have to move it back 1,000. So 3 decimal places would do the trick. So this right here would be our answer. For number 12, we have a 2/5 raised to the third power, so let's go ahead and expand this. So this will be 2/5 multiplied by 2/5 multiplied by another 2/5 here. All right, let's see. In the numerator, 2 times 2 is going to be 4. 4 times 2 is going to be 8. Let's go ahead and write 8 for our numerator. And on bottom, we have 5 times 5, which is 25. 25 times 5, let's go ahead and do that on the side here. 25 multiplied by 5. That's going to be 25, carry the 2. 5 times 2 is 10, plus the 2 is going to be 12. So we're really looking at 125 for the denominator. All right, for number 13, we have 8 to the 4th power, which is really just 8 times 8 times 8 times 8. If I'm going to go ahead and set this up, I know 8 times 8, that's going to be 64. And I know this 8 times 8 is also another 64. So let's go ahead and multiply 64 by 64 here. Okay, so let's go ahead and multiply that out. 4 times 4 is 16, carry the 1. 4 times 6 is 24 plus 1 is 5, so it's 256. Put a placeholder here. 6 times 4 is 24, carry the 2. 6 times 6 is 36, plus the 2 is going to be 38. All right, let's go ahead and add these two rows together. We have a 6. 5 plus 4 is going to be 9. 2 plus 8 is going to be 10, carry the 1. 1 plus 3 is going to be 4. So we can go ahead and write here that 8 to the 4th power is going to be 4,096. All right, for number 14, we have 7 cubed, or 7 to the 3rd power. So this is going to be 7 times 7 times 7. Now let's see, 7 times 7, I don't need to write that out. That's going to be 49, but it might help to write out the 49 times 7 after that, right? I think we already did one of these earlier in a previous problem. Let's see, 7 times 9 is going to be 63, carry the 6. 7 times 4 is 28, plus the 6 is going to be 34. So that's going to be 343. All right, for number 15, we have a decimal here. We have 3.6 squared, or 3.6 raised to the 2nd power. So 3.6 times 3.6. Let's go ahead and see what that's going to be. Again, when we're multiplying, let's go ahead and just ignore the decimals for now. Let's make each of them 10 times bigger. So let's do 36 times 36, then put the decimal back in later. 6 times 6 is 36, carry the 3. 6 times 3 is 18. 18 plus 3 is going to be 21. Put a placeholder. 3 times 6 is going to be 18, carry the 1. Then 3 times 3 is 9. 9 plus the 1 is going to be 10. So if we go ahead and add these two together, we're going to have a 6, a 9, a 2, and a 1. We ignored 2 decimal places, so our answer is 100 times too big. So let's go ahead and put the decimal back in here and put our answer as 12.96. That makes a lot more sense here. So we'll go ahead and put 12 and 96 hundredths as our final value. All right, for number 16, let's go ahead and expand 2 1/3 raised to the 4th power. Again, I'm going to turn this into an improper fraction. So big bottom plus the top, or 2 times 3 is 6 plus 1 is 7. Really, this is 7 over 3. And we're going to have how many of these 7 over 3s? I think we're going to have 4 of them. So let's go ahead and write 4 of these 7 over 3s as a product. Okay, so let's see. We have to figure out what the numerator is going to be. So 7 times 7, that's 49. And we have another 7 times 7, that's another 49. So for the numerator here, let's go ahead and figure out what is 49 times 49. All right, so let's see. 49 times 49. Let's see. 9 times 9 is going to be 81. Carry the 8. 4 times 9 is going to be 36. 36 plus 8 is going to be 44. So we have 441. Put a placeholder. 4 times 9 is going to be 36, carry the 3. 4 times 4 is 16, plus the 3 is going to be 19. If you go ahead and add these two together, our partial products, we're going to get 1, a 0, a 1. I think this is going to be a 4, and then a 1, and then a 2. Okay, so I think our numerator here is actually going to be 2,401. All right, for our denominator, we have 3 times 3 times 3 times 3. So the first two 3's here are going to make 9, and these two 3's are going to make 9. 9 times 9 is going to be 81. Now, if you want to write this as a mixed number, you can, but I'm just going to leave this as an improper fraction. That's fine. All right. For these last couple problems for 17 and 18, let's see what we're going to be doing here. We're going to go ahead and determine the error that was made in each of these examples and say why it is incorrect. So we have to find out what a mistake is that is below and why it's wrong. Then we should show what should be done so that we could get the right answer and actually solve it so that we know what the correct answer should be. So for number 17 here, Benny evaluated or solved the power 2 to the 5th power and got an answer of 10. So what is the error here? Well, let's see. We hopefully can say that 2 to the 5th power does not equal 10, right? So we know that's wrong. So we have to say what is going on or what happened that we got this wrong answer or Benny got this wrong answer. Now, how could Benny have gotten 10 from 2 and a 5? Well, I'm thinking that maybe Benny had actually said that 5 times 2 does equal 10. That's true, right? So maybe we can say that Benny must have multiplied the base and the exponent together, but that is wrong. That is not how you or Benny should be evaluating powers. So how do we evaluate powers? Well, if we have 2 to the 5th power, remember that this actually means, let's help Benny out here. It should be 2 times 2 times 2 times 2 times 2. It's a longer multiplication sentence here. And 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this should be the correct answer. So when Benny did 5 times 2 is equal to 10, he's kind of like saying that there are 5 of these 2's being added together, because 5 times 2 just essentially saying you have 5 2's being added together. So over here on the left side, Benny actually kind of maybe said that he thought 2 to the 5th power was repeated addition, but that is incorrect, right? Actually 2 to the 5th power is repeated multiplication. So it actually gets bigger much faster. All right, let's check out number 18. For number 18, we have Ernie evaluated or solved a power, 3.5 raised to the 2nd power, and got a value or an answer of 9 1/4. So what's wrong with this one? Well, let's go ahead and just write it down first. Ernie's saying that 3 1/2 raised to the 2nd power is equal to this 9 1/4, right? But is that true? I don't think that's true, right? So let's start by just writing down what we have here. Ernie's saying that this 3.5 being raised to the 2nd power is equal to 9 1/4, but we know something is wrong here. So let's go ahead and just put a slash through this equal sign. Now, I guess it's possible. Now, what did Ernie do to get this answer of 9 1/4? I guess it makes sense. It's possible that he might have done this 3.5 times 3.5. Right, if he wrote it out like this and kept them as mixed numbers. But I think that maybe what he did here was then he took this 3 and 3, I guess, and multiplied 3 and 3 together to get the 9, right? This would be equal to 9. And then I think what he did after that was he multiplied maybe the half and the half together, because a half times a half is a quarter. And then I think he maybe just like squashed these two pieces together to get 9 1/4, right? I think that's maybe what he did. So, well, that's a little strange, but that's a mistake that other people might make sometimes. So I think what Ernie did wrong was he multiplied the whole numbers and the fractions together, which is not how you multiply mixed numbers together. So that is wrong. So over here, this is not how you multiply fractions together, or mixed numbers rather. We always will turn our mixed numbers into improper fractions. So what should he have done, or what would you do? Hopefully, you would take this 3.5 raised to the 2nd power. If you saw this in the future, you would go ahead right away and turn this into an improper fraction. You do 3 times 2, which is 6, plus the 1 on top, which is 7. And you would say to yourself, oh yeah, this should be 7/2 raised to the 2nd power. It's another way of writing it. And you might avoid that mistake, and you could write this as 7/2 times 7/2. Right? And you would know that that would be the correct way of writing this. Now, you would then know 7 times 7 is 49, and then 2 times 2 on the bottom is going to be 4. And then if you really wanted to write this as a mixed number, because I think a lot of times people will like to see that as well, 4 into 49, let's see, it goes in 1 time into there, that's really a 10. So that's going to be a 4, remainder of 0, bring down the 9. 4 into 9 is going to be 2 times. 2 times 4 is 8. We get a remainder of 1. So we can see here that 4 goes into 49 12 whole times with 1 left over. So that's going to be 12 1/4. And that's what actually the answer should be. You can see that this is not the same thing as this 9 1/4, and that this is the correct answer over here. All right, so there you have 18 different practice problems that helped you hopefully understand powers just a little bit better. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.